just to straightforward to tell you the goal, what we want to do is to have a better picture of the center foliations, and then put the title so everything makes sense. It's concerning the absolute continuity, the rigidity, and disintegration. And I mean, we're going to see what do I mean by these things, but to already tell you, we have seen from the talk of Marcelo Viana, he talked about these things, and so he has talked about time one for nozzle flows, but in the end, what happened is so we want to kind of see the same things for DAs, because for kind of like the other ones, as like time one or skew products, they basically have got many results. I will write the results, but just to, kind of tell you what we are concerned on. So let me write then the definition, and then we start to see better what's actually going on. So to already tell you when I mentioned partially hyperbolic, I'll be working on with the splitting, and they all one-dimensional, and I'll be working with it. My partially hyperbolic, when I say more to the end, is more like the absolute partially hyperbolic one, which is essentially the contractions, they're always uniformly smaller than some constant, and the expansion uniformly greater. We have seen the definitions, and also I want, just lose too much time on that. Okay, and another thing, one definition I want to mention here is so suppose we have a compact manifold, and the Borelian sigma algebra, and then we consider mu a probability. I'll say that a partition of M, so this is a partition. I'll say that it is a measurable partition. If there exists a set of full measure and countable number of measurable sets, such that every element of the partition, so consider an element of the partition, and then we intersect with this full set. So each element can be obtained by, I'll just write like B sub I, then we intersect always with the F, and B sub I is just D is the same. It's just one of those initial sets here. Okay, and then let me put the disintegration theorem, which one we're going to use, the Rocklin disintegration theorem. So in this context, if we have P a measurable partition, then we can disintegrate our measure. So there are this M sub P will be conditional measures. So let me write what we have is, so consider a measurable set, then we can disintegrate in this sense. And this mu hat is this push forward here. It's a push forward of mu where pi goes from m to our partition. Okay, and then let me now then kind of just state very briefly the theorem that Marcelo Viana showed on his talk, which is so although he was telling about perturbations of time one of another flow, he has mentioned that there are some extensions, and then I'll just put here also for this extension, which is so for, I'll just write for certain partially hyperbolic with so the splitting are also like the one I put there, they're all one-dimensional. For certain, so perturbations, right? Okay. Of time one of another flow and this Q product. What he has obtained is, what they have obtained, he wrote on his talk, which is, so basically, it's just kind of like hand waving, but so Marcelo Viana was kind of the introduction for this. But anyway, the idea, let's not bother too much, but one thing is, I'm always concerned on volume preserving partially hyperbolics. Okay, so what they got is, if the center foliation, okay, I'll just write and then mention what is actually the absolute continuity. If the center foliation is not absolutely continuous, then I'll just use here, I'll just write atomic. He said that you have atomic disintegration, which is you will have a set of full measure which each leaf are going to intersect this set on one point, on like k points. Okay, and the other thing that he mentioned, so in fact the absolute continuity is kind of like a rigid thing. So he wrote that if the center foliation is absolutely continuous, then what they have got is that so this partially hyperbolic is in fact, just write smooth. It's smoothly conjugated to I'll put rigid model, because there are different partially hyperbolic. But anyway, if you remember, so if the center foliation is absolutely continuous, what happens is this partially hyperbolic is smoothly conjugated to this rigid model. And he was mentioning about the perturbations of time one of another flow. In this sense, it meant that this perturbation comes, in fact, from time one of another flow. But in particular, so the center foliation is smooth. Okay, let me just remind you that what we are calling I'll put already be considering the center foliation. So the center foliation is absolutely continuous. So this is the definition. If so we have to look locally and then consider this like foliated box, and then we have the center foliation here. We say that the center foliation will be absolutely continuous if we disintegrate with the Rockland theorem. These measures, they are Lebesgue. So because since we are going to be concerned a little bit on the conditional measures, actually Marcelo Viana did not actually put on this term, but he mentioned about sets of full measure intersecting almost every leaf on almost every point, things like that. But I mean, it's the same thing. Okay. So when he said that, when we say that the disintegration is atomic, it means that if you look locally there, these conditional measures, they are like direct measures. Okay. So I put the theorem there because then what happens is, so what can we say for the other? So those partially hyperbolic, they are on three-dimensional manifold, as I mentioned. So we're working with each one is one-dimensional. And so what can we say about, for instance, DAs, diffeomorphism? Okay, so that's what kind of results can we obtain? So if you look from this result, so it makes sense to look things as, so rigidity kind of means on that sense, so does absolute continuity imply some kind of rigidity? You know, well, this is the meaning. And this is why we want to look for DAs. And, okay, what I mean by DA are, it's partially hyperbolic with homotopic to the linear Anosov. And, okay, so we'll be working on the three torus. So let me put what can we say, the things we can say concerning, for instance, when we don't have the absolute continuity. Okay. So the first two ones are in fact we'll be working on the Anosov diffeomorphism, and so it's the I'll write like this, for partially hyperbolic Anosov, because what I mean is they have like three real eigenvalues, so that's why that's the meaning of the partially hyperbolic Anosov. On T3, and I'm always concerned on it's, again, just write like volume preserving. So for Anosov on T3, volume preserving, and the center, so, you know, as I told you, although it's an Anosov, I'll be looking the middle splitting of the tangent one as given the center foliation. So the center foliation and the center foliation not absolutely continuous. Then let's see the things we can say about it. So the first thing we can see that it's a different behavior from what they got from the other types of partially hyperbolic ones is that in this case, so there exists diffils. So I mean, so this one's another ones, there exists diffils such that the the disintegration is neither Lebesgue, this is, in fact, from the hypothesis, nor atomic. So this is the one first different kind of behavior we get from the other types of partially hyperbolic they got. And just mentioning, when I say disintegration is, again, have to look locally. I'm not saying I'm disintegrating when I look the center foliation as the partition, as we're going to see here. Although this is not atomic, if we had atomic disintegration, because the thing is, although we got this example, we don't know if we do have atomic or not. I mean, these are some anosophones. If it's atomic, then it's, at least in this case, it's 1 atom per leaf. And the meaning is that there is a full set which intersects each center leaf on one point. And the one other thing concerning the atomicity is if, okay, so if I write, if atomic, if the volume disintegrating on the center foliation, the conditional measure atomic. No, because I'm working, no. They are the anodes, they are lines.
So it would not be a measurable partition.
Yeah, that's what I'm kind of mentioning, that it's when I'm saying, it's kind of, so when I say that the disintegration, it's locally, you look.
Locally,
Yeah,
what does it mean to say that it's 1 point?
yeah, in this case, this is the same as saying that there is, so in this case, it means that there is a set of full measure which each leaf intersects this set on 1 point. Okay, so for this is, this is the meaning, let us say, for this one. But just mentioning really quickly, yeah, after then. Another thing concerning the atomicity is, so atomic, I'll just write like this, atomic disintegration. And now it has also to do concerning your question. And so, in fact, now I'm saying that these center foliations, the partition in the 3 torus, the center foliation is a measurable. So in this sense. So now if it's atomic in this sense, for instance, locally, if the conditional measures, they are atoms, then in fact, this partition is measurable. Okay. And okay, so this is concerning the non-absolute continuity. What can we say about the absolute continuity? So, once again, we have a different kind of behavior, which is for, just write again to make things clear for, so it's, there exists F, so Anosov, and then I'm always on volume preserving case, such that the center foliation is absolutely continuous, but F it's not conjugated to its linearization. just to put on their term. So we don't have that kind of rigidity. And let me just write here in fact, an important result, I'll just put it, say lemma, and which is for, okay, so it's a lemma. In the same context, another volume preserving, we have that this guys like this, another partially volume preserving. So they are C1 conjugated to its linearization if and only if if we look to all the periodic points and they have it's constant on each of these directions. So in the end, this theorem will be will come just from just changing things perturbing on periodic points. Okay, so in the end although we do not have this kind of rigidity as they have obtained for the other types of partially hyperbolic, we still have some kind of rigidity, which is, so now over there we were considering actually on another ones, and so just making, so I have written that. So if F is a dA, so this partially hyperbolic, I'm going to talk to the linear one. So if F is, just put like this. So if F is a dA diffil on T3, volume preserving, and so now we ask something more to get a rigidity. We ask, so the absolute continuity was not enough. We asked then and the center foliation is C1. It would be good if we could have the rigidity here, but we had a technical thing here, which is the center holonomic. So in fact, since we are on T3, our partially hyperbolic, they all have, like, for instance, center stable, center unstable leaves. And what I want to say here is that, so I can look the center holonomy inside these leaves, and then I add the hypothesis that the center holonomy, it's uniformly Lipschitz on CS and on CU. Okay, now, and then we can get some kind of rigidity. Then F then will be C1 conjugated to, so the A here, it's the linearization. So F is C1 conjugated to its linearization, so in particular, so F is another, right? And just to, as time is running out, just to mention one other, so, okay, it's not clear yet if having this strong condition on the center foliation, if it could somehow imply the other thing. And, okay, so for just coming back here, we saw that we can have for Anosov ones, on the Anosov set, we can have a not atomic disintegration. It's not clear if for all the Anosov ones we have this behavior, for instance. But, okay, so let me just mention that we do have dA, so it's volume preserving on T3, but in fact not Anosov this time, which the output with atomic disintegration on the center leaves. Okay, and that's it.